Hey, cybersecurity students. In
Welcome
today's
back to
episode of our Cybersecurity Concepts series, we're covering a classic but extremely powerful vulnerability that every cybersecurity student must understand. Buffer overflow, even though it's one of the oldest vulnerabilities. Buffer overflow attacks are still used today to crash systems, gain control, and execute malicious code. Let's break it down in the simplest way possible. A buffer overflow happens when a program tries to store more data in memory than it was designed to handle. When this extra data spills over, it can overwrite nearby memory. And that's where the danger begins. Think of a buffer like a cup. If you pour more water than it can hold, it spills everywhere. In computing, that spill can overwrite critical system instructions. How buffer overflow works program. Allocates fixed memory. A program reserves a fixed amount of memory for input. Example, username buffer equals 8 characters. 2. No input validation. The program does not check how much data the user enters. 3. Attacker sends oversized input. Instead of 8 characters, the attacker sends 100. 4. Memory gets overwritten. The extra data overwrites, return addresses, function pointers, system instructions. 5. Attacker gains control. The attacker can crash the program, run malicious code, gain system access. Why buffer overflow is so dangerous? Buffer overflow vulnerabilities can lead to remote code execution, RCE, system crashes, denial of service, privilege escalation, full system compromise, malware installation, root or admin access. Many famous worms and exploits were built using buffer overflows. Cybersecurity impact. Why it matters. Buffer overflow attacks affect operating systems, web servers, network devices, embedded systems, IoT devices, legacy software. Because many systems still run old code written in unsafe languages like C and C++, buffer overflow remains a serious threat. Real-world examples, Morris worm. One of the first internet worms used buffer overflow. Heartbleed-like memory issues expose sensitive data by reading memory. IoT and router exploits. Many router attacks rely on memory corruption. These attacks show how a single bug can impact millions of systems. How attackers exploit buffer overflows. Attackers often inject shellcode into memory, overwrite return addresses, redirect program execution, gain command line access. This is why buffer overflow is heavily studied in penetration testing and exploit development. How we defend against buffer overflow attacks. Secure coding practices, validate input length. Use safe programming languages. Languages like Python, Java, and Rust manage memory automatically. Stack canaries, detect memory corruption. Address space layout randomization, ASLR, randomizes memory locations. Data execution prevention, DEP, stops execution of injected code. Regular patching fix known vulnerabilities quickly. Why cybersecurity students must learn. This understanding buffer overflow helps you learn how low-level attacks work, understand memory exploitation, analyze malware behavior, perform vulnerability assessments, think like both attacker and defender. If you plan to work in penetration testing, exploit research, malware analysis, SOC engineering, OS security, this knowledge is essential. Buffer overflow attacks prove that even small coding mistakes can lead to massive security breaches. By understanding how they work, you gain the skills needed to secure systems, detect attacks, and defend modern infrastructure. If this video helped you, hit like, subscribe, and turn on notifications for more content in our Cybersecurity Concepts series. Stay curious, stay secure. See you in the next video.